Welcome everyone, and thank you for joining today's webinar. What if I told you that the next major outage at AWS, Azure, or GCP would not impact your business at all? I'm Ross Beard here with Shadowsoft, a premier Red Hat business partner, and alongside me is our chief architect, Derrick Sutherland, who's been working with Red Hat, containers, and cloud-native technologies for over 10 years. Derrick has coined the new term infrastructure agility, and he'll be showing us how to break free from vendor dependency and build truly agile infrastructure environments. I'll pull up the slides now and then over to you, Derrick.
Cool. Thanks, buddy. All right. So today we're going to talk about a lot of interesting concepts, things that have evolved, things that have changed, new opportunities that we have to really capitalize on some cloud native technology sets that will allow us to do things that I would say, I don't think people even really thought possible previously. So with that, let's go right into it. So traditionally, when it comes to modern infrastructure, there's a lot of different things that are part and parcel a problem that usually needs to be dealt with. Thing number one is, obviously, we're thinking about vendor lock-in. When people are thinking about vendor lock-in right now, probably what most comes top to mind is what's gone on with the Broadcom acquisition of VMware and all the different changes in pricing models and people looking just for something else that they can go to. Now, the true and reality is that plays also to every major cloud provider. Most companies, not all, but most companies end up selecting one major cloud provider, whether it be AWS, Azure, GCP, and then they usually keep some level of on-premise workloads living in something like a VMware solution as it relates today. The problem with that kind of mindset is ultimately you're going to be functionally moving around more than likely based on what's most cost efficient at any given time. So you're hearing frequently about clawback and things like that, and customers frequently considering, hey, I'm inside of AWS or Azure, maybe I want to move some workloads back to being on premise. And this we kind of foresee is going to be a back and forth thing. So that's thing number one. Obviously, when you're locked into these environments, it obviously becomes quite complex with making those movement switches. Thing number two is disaster recovery becomes really complex because when you have some workloads living in a cloud provider and some on premise, obviously they're built on entirely different technology sets, and you're dealing with solutions that are pinpoint to the given environment they live in. There might not even be an equivalent in another environment, whether it be a distinctly different cloud or something that's more like a customer-owned data center. So obviously the strategy around this gets really, really, really complicated very quickly. With that, we also have the combination of different legacy virtualization stacks. Obviously, VMware has been a premier provider for virtualization on premise, but they have not been the only solution in that space over time. But regardless, those solutions are really built on traditional IT infrastructure, and they haven't really become what I would consider cloud native in the sense that you still have to deal with networking requirements, how you're doing service discovery, ticketing processes. When you want to bring a system back online, you have to use an external third-party system to usually do that or automate it in a different way. And then there's limited awareness of other kind of competing solutions in the space and what they have to offer. And those solutions, when we start thinking about things like OpenShift, can really challenge the way you do things from a traditional IT infrastructure. And that begins first and foremost with building things in a way that are not only either container native, but can support virtual machines, but ultimately allow you to do everything in a software-defined manner, no matter where you are. You want to go to the next slide? So I briefly spoke about the VMware Broadcom acquisition. This has obviously been creating a lot of heat and thought around, hey, maybe we're looking for an alternative to VMware strictly from a cost rationale, but maybe we're also looking for something different since this is happening because we're trying to introduce something new into our environment that may be more efficient for some of these future workloads. In addition to that, we see a lot of different distinct issues that have been going on recently. I'm sure many people are aware there has been issues with different cloud providers. One issue, for example, even just last couple of months, AT&T and AWS had some connectivity issues. That wasn't particularly, I would say, on either organization's fault per se, but the problem was still there. And if you were on, say, AT&T internet and you were trying to reach an AWS US-based service that was SaaS-based, so any application that might be living in AWS, if your internet provider was AT&T, you weren't able to route to those services. So it appeared they were offline, even though technically they weren't. These kind of things happen all the time. And it's not just, one particular cloud provider, but it has to do with the way traffic ultimately gets to the source. Sometimes it has to do with infrastructure survivability, and sometimes it has to do with the overall networking topology. But either way, we need to be cognizantly aware that living inside of one distinct environment, whether it be on-premise, in one data center and multiple data centers, we need ways to safely move between these environments seamlessly. And this only gets doubled down further when we think about the number of data breaches that go on every year. In 2023, there was 3,200. Last year, there was like 3,150-ish. And each one of those cost $4.8 million on average to be able to support the actual recouping of what ends up happening. So if you think about that at scale, the number of companies that are getting impacted and the ways that we're trying to mitigate that risk traditionally has been, well, someone broke in. Well, now we got to make sure they got out, which is important fundamentally. But what if there was a different way? What if at the moment we notice a breach, we could literally get our infrastructure out of the environment where it lives? This would change our entire way of how we think about security breaches, simply for the simple fact that if it ends up being an infrastructure related, provider problem, maybe we don't have to be isolated into one place. Maybe we could move somewhere else and circumvent the issue entirely. Next slide, Ross. So this is where we start thinking about how can businesses be more flexible in terms of their environments? How can they be, when I use the word resilient, I'm thinking about how can they be infrastructure agile? In other words, how can they move from one environment to another? So that way, if connectivity is lost, if a data breach occurs, if things become more cost prohibitive, how can we get to a place where we don't have to necessarily deal with those issues? So I think this is where we start thinking about how do we shift away from these traditional mentalities? And part of that is becoming aware of what the art of possible is, which I think people are looking at a lot of different solutions, like what does AWS provide? What does Azure provide? What can VMware give me? And they're not traditionally thinking outside the box in terms of what those solutions were designed for, and ultimately, what's the end goal destination? And in order to do that, we really have to start from the end goal and work our way back. So part of this is shifting away from a single cloud strategy. I think everybody initially did that for negotiation reasons, maybe partly tied to cost. Some of it was also tied to not wanting to learn the skill set of multiple cloud providers, and that's totally understandable. It can be overwhelming, and the cost of managing those teams to know these different environments obviously becomes problematic if you don't have a way of simplifying them. So really what we should be talking about is how can we run workloads across all these different providers and not have to be thinking about the big picture, how all these different providers operate. At the same time, how can we seamlessly go from one environment to another and changes based on either security or cost events, be able to automate that process so we don't even have to think about, hey, at this given time, should we be in this environment or should we be in another environment? How can we seamlessly move between environments without having to worry about the overall overhead of it? The challenge is traditionally it hasn't been cost effective and really not even possible, especially when you start taking in storage into consideration, when the storage inside of AWS is going to be completely different than it is on premise, completely different than it is in a different cloud provider. Maybe some of the protocols are similar ultimately, but how are we going to be able to have that storage be immediately available in these different environments? And that's where things get tricky. So the art of the possible with infrastructure agility starts with Kubernetes and OpenShift. The reason why we talk about it from this perspective is because, first of all, every one of these environments has one unique thing that makes them always the same. And that's the operating system layer up can always be Linux. So once you're in VMware, once you're in Azure, once you're in GCP, wherever, you can run RHEL or CoreOS on any one of those environments. And what that opens the doorway to you is, now I can do that with Kubernetes on top of it. So what does OpenShift bring to the table in this regard? Is it's a fully managed Kubernetes platform that can be used for any one of these hybrid environments, simplifying not only what we're going to be able to be targeting from a workload migration perspective and how, unique things will be in different environments. We can simplify it down to, hey, it's OpenShift everywhere. And at the onset, the only thing we need to worry about from these different cloud providers is how to monitor something like cost and how to spin up that OpenShift cluster initially, which, wink, wink, nod, nod, is all automated for you out of the box. So you can get the vast majority of these things pre-provisioned for you just by knowing OpenShift. So if we dilute all those capability sets down, we lose the risk of ultimately spending too much time in how do these different environments operate. So that then comes to the mindset of, what does OpenShift and Kubernetes bring to the table? Well, first of all, we're talking about the ability to have software-defined networking that looks the same everywhere. The same security and compliance style of ruling that applies everywhere, since the network layer, the storage layer, how containers run, even how virtual machines run is going to be the same in every environment. Now, full disclosure, AWS, you can run bare metal right now. So I can put OpenShift in AWS that's bare metal with VMs running on it. I can do the same on premise, and it's coming to all the other major cloud providers. So at this juncture, we're looking at an ability to run both containers and VMs in the same platform, no matter where you are. The other thing is Red Hat's ecosystem and IBM's ecosystem ties into all this with Ansible to automate the things that are interconnected around these different environments. So when it comes to things like the load balancers that are allowing traffic into OpenShift, we can use tools like Ansible to change Route 53 or DNS entries. We can use it to change our load balancers so that they're pointing at new environments. We can bring in third-party tools like Dynatrace, for example, to do monitoring of the health of different environments and use workflow automation to have Ansible automatically kick off jobs for when, say, a disaster event occurs. Again, it's multi and hybrid cloud enabled. So you can put it on bare metal. You can put it on VMware if you just want to run containers. You can put it into AWS. You can put it in any one of the cloud providers. And with that, because we have all these combined capability sets, everything is done the same way, again, everywhere. So we're talking about service discovery, the way we do software-defined storage, the way we do network policy management, how we do CI/CD. It all remains the same no matter what environment we're targeting. So not only is it simplifying the skill set down, but it's allowing more art of possible when it comes to doing things like moving workloads from one environment to another, because ultimately they're literally the same environment. So by living in a unified Kubernetes platform, one of the things we have the ability to do is have, again, shared storage between these different environments. So for example, if I wanted to have a hot style scenario where I had a cluster in one data center and a cluster in another data center be literally having the workloads pre-ready all the time, we could leverage a solution like Portworx, which if the environments are under 10 milliseconds of round trip latency, we can have a single storage cluster go across both of them, where workload storage is getting mirrored from one Kubernetes cluster, one OpenShift cluster to another. This same concept applies to the cloud, as long as you have the ability to have that round trip latency that be that low. Now, in the event you can't, well, because of the regional lockage, maybe we're East Coast and West Coast for how our data centers are separated. It's a little bit longer. We can also go to a best effort model where we can get things, maybe not immediate sub-second available, but maybe they're within 1 to 2 minutes available in terms of, RPO and RTO. So with that, we start looking at what is the art of possible for these things. If I have virtual machines and containers living inside of an OpenShift cluster on premise in, a data center that is within 10 milliseconds of another data center, and in that separate data center, I also am automatically deploying those same VMs and containers into that environment, that storage is being shared. So we can route customers to one cluster And in the event that cluster either needs to be decommissioned or moved over for any particular reason, again, cost, security, whatever, we can turn off with Ansible, automate all of it, that cluster to be shut down, and workloads inside of your load balancer to be redirected to this new cluster. And again, this isn't just stuck to one environment. It works with every environment.
So Derrick, everyone loves a good architecture diagram. Talk us through this one.
Yeah, so imagine for a second, and I don't know if, I don't have presenter control, but imagine for a second, we have an application that's in a data center, and that application goes offline. The storage can be mirrored via Portworx to another cluster and another cluster. So as these clusters fail, if they ever do fail, or as you shut them down for different graceful reasons, again, cost consumption, for example, we can have it pummel through a load balancer and be automatically redirected to one of these other clusters. Now, let's say also, for example, well, maybe some workloads have to run in one data center versus another, and we need them to stay intercommunicating with each other. We can leverage tools like Scupper, which is depicted here, as an overlay network to have OpenShift workloads in one cluster be able to service discover and communicate with services in another cluster using a layer 7, more or less VPN. It's not quite the same as a VPN. It's a little bit different because obviously VPNs operate at a lower level like layer 3. But ultimately, you can have traffic from one cluster be able to communicate to another cluster as these things move. So if I have workload A running in data center A and it shifts to data center B, Scupper's aware of the fact that that application is inside of both of those environments and can choose where to send traffic based on what's the slowest response time. So we have tons and tons of capability sets to be able to have OpenShift clusters, be able to have workloads intercommunicating and moving between one another. And ultimately, this is something that wasn't possible when you considered other different disparate environments. Why? Because those environments were too unique onto themselves. AWS and Azure do things differently. VMware does things differently. But with the operating system level up being the same everywhere, we can have Kubernetes everywhere. And that means a unified way to manage workloads no matter where they are, and unified APIs for how to integrate with all of them. So what's the benefit here, and kind of what's the art of the possible? I think some of this speaks for itself. Some of this, if architected right, is going to make you way more cost efficient. You can determine, I mean, you could set up, let's just say, for example, in Dynatrace, cost monitoring rules for the different environments you're in. Maybe you're using pay-as-you-go subscriptions inside of your different cloud providers, and you have Dynatrace monitor when things start to get a little bit cheaper in one environment or a little bit more expensive. You could use that to automate a workflow to update your load balancer to target a new environment. And once traffic shifts, you can use that automated workload to shut down, or let's say scale down another environment. So you're not wasting dollars on different instances and different cloud providers. In the event that there's a disaster recovery event, you're hot essentially anywhere. And even if you're hot warm because of data latency between them, ultimately you're reducing your disaster recovery time ridiculously because all of your workloads are already pre-provisioned in these different environments. And even for example, if you said, well, we want to have things pre-provisioned for disaster recovery reasons, but we don't want to pay for that cost. That's okay. You could have those clusters in these different failover environments be scaled down to the smallest footprint size possible for storage to mirror over. And then in the event that you have a failover event, it's as simple as calling that cluster's node groups to scale up to meet the load of your new workloads and redirecting your load balancers, which again can all be automated with Ansible. The real nook and cranny of this is, and this is the thing that I want to hammer home, I think people, when they're considering alternatives in this environment, in this world, for what they're doing on premise in a given cloud, or what they're doing with VMware for a different virtualization provider, people traditionally look for things that do capability-wise the same thing as their old solution did. And I think that is understandable, but it's to a fault because we're not considering what possibilities are out there for how we can do things in genuine better. I mean, the average disaster recovery time for many companies can be anywhere from hours, which is on the low end side, to days or even weeks, depending upon how big of an outage their environment has. But because we can automate things in such a distinct way with these kind of solutions, we could maybe get it down to even minutes for where we're being able to fail over to new environments, maybe even less if we're doing true hot, all depending upon how much you've automated and how much you've hooked into this ecosystem of tools. So I think this is a really big, important point in our time. And the reason all this is possible is because this solution has been around for 10 years, and there's so much of a community adoption that now it's become much easier to integrate all these additional capability sets that I think some people don't even realize, even people in the Kubernetes communities don't realize are in the art of possible. Now, historically, as I made mentioned, why was this not something that was advertised or talked about sooner? A lot of these capability sets weren't as developed as they are now. And it used to be very complicated to set up a lot of different things. Storage became a bit of a challenge, especially from a stability perspective or replication perspective, but so much has advanced over the last several years. Scupper and Submariner, which are different kind of service interconnects for clusters, didn't exist a few years ago. And now they give us the ability to do either layer 7 or layer 3 traffic between all these different clusters rather easily without very much work. Tools like Portworx have been around for years, but they've gotten so polished at this point that now it's very push-click easy to install inside of an environment for the most part, with some caveats around that. And really what's important is making sure that you're architected appropriately for these different types of use cases and benefits. So ultimately what I'm saying is this ecosystem has evolved drastically over the last 10 years, but especially over the last couple of years to solve different unique use cases. And I really think we're approaching a bit of a singularity where, in what I mean by that is these tools have grown so well ecosystem wise that it's going to become extremely easy to solve problems that didn't even perceivably were possible previously.
So we have a lot of customers or organizations coming to us looking for a VMware alternative. Is OpenShift a replacement, or?
I think it's a complicated question. The short answer is no. It's not a replacement, but I want to put a big asterisk on it. It's not a replacement because it doesn't do things the way that traditional virtualization providers did things. VMware has no concept of software-defined networking in the concept that OpenShift does. VMware doesn't have a concept of service discovery or service meshing. It has no intercommunication between itself and a continuous integration and delivery solution. It's just so fundamentally different. Now, does it run virtual machines like VMware does? Absolutely. But from the context of the way that containers traditionally have been run inside of Kubernetes, which means that a VM, when it runs in Kubernetes or OpenShift, is running inside of a pod. The same construct that containers do. It's a small KVM instance, Linux kernel-based virtualization, that is running your VM, and it gets all of the benefits of all the toolage that already existed inside of OpenShift for the last 10 years. That's a lot of benefit and power, and I think it's an angle of things that people aren't experiencing. So the reason why I say it's not a quote-unquote replacement is if you're a traditional infrastructure engineer and you're looking for that same look and feel UI that you had over the years and the kind of what I would say rudimentary required functionality that VMware had, this is just different. The different is good in this regard. It's going to make your situation better for you. But that difference is also going to be, it's going to require upskilling and reskilling of your engineers to understand how does scheduling work in OpenShift, how does VMs ultimately scale out, what are the new things that I can do with this, and how can I retool my environment so that way containers and VMs are managed in the same way. So it's not a replacement, it's better.
So it's not a one-to-one replacement, but it's a better way to manage VMs.
Yes, in my opinion.
So how about roadblocks to executing this vision of infrastructure agility?
The biggest thing is it goes back to lack of awareness. And I don't just mean Kubernetes possibilities. I mean lack of awareness of Kubernetes, really. I think the if you go to the CNCF website where they show all of the different tools that have been built in cloud native, the number of solutions that are specific to Kubernetes in that subsect is the vast majority. And there's just thousands of different things ecosystem-wise. And that can seem overwhelming. And quite frankly, it's a lot to take in from a learning experience perspective. So I think people, their eyes almost glaze over when they look at that and they go, I just want to learn Kubernetes. And they come into it with the mindset of looking at things from a traditional infrastructure lens. They don't come into it looking at it as, what is this from the ground up and how is this different? What's the reason this exists? Like kind of looking at the historical purposes behind things so they can see that again, art of possible of what they can fundamentally do. I think another big roadblock is people tend to invest in the technologies that they've had for years and years and years and years. And that obviously makes sense, but that also inhibits them from being able to bring in new technology because it's so different. They are going to have a hard time upskilling their engineers. And by hard time, I don't mean that learning OpenShift is particularly challenging, but what I mean is they don't usually have the time. A lot of times people are spending hours just, they're all of their days keeping systems up and running. They're not thinking about how can I have enough time to relearn a new solution while building out what I currently have today. I think also there's a pretty big assumption that no matter where you are, that there's going to be some cost savings. I mean, look, you can use major cloud providers in a cost-efficient way when you're using things like reserved instances, cost-saving plans and stuff. It can be much more cost-effective, but at the end of the day, it's not quite as cost-effective as having the ability to nimbly switch around environments based on what's cheapest. I mean, quite frankly, how many people go to the same gas station every time they go for gas? Never, right? They go where the gas is the cheapest, usually in relative retrospect to where they're living. So ultimately, I say all that to say, having that kind of flexibility, I think will change the way also that cloud providers fluctuate costs. But at the end of the day, and this is probably the last one, I think, and this goes back to lack of awareness, there is a mindset that Kubernetes is really difficult. And from one sense, it is in that it's different. But different does not mean difficult. Different just means different, right? I've used, OpenShift for 12 years now before it was even Kubernetes based. And I've used Kubernetes since it's been adopted, which is a little over 10 years. It's getting close to 11 years. And I will tell you this, if you learned 11 years ago, it was rather difficult because a lot of things weren't where they are now. But at this point in juncture, there's so much training available. There's so much information available. It's just different. The way scheduling works is just different than traditional virtual machines. And even a lot of things that worked in traditional virtualization layers have carried over to try and make the mind shift jump a little bit easier. I think it's really more a matter of appetite and desire to be willing to learn something different. And as you have more and more seasoned individuals in their careers, quite frankly, most people don't want to learn something new. And that's where this difficult mindset comes from.
Great. Thanks, Derrick. Now, we've got some common questions that we always get asked when it comes to infrastructure agility. Let's go through a couple of these, and if anyone else has any questions, you can pop them in the chat. But Derrick, how does OpenShift's approach to infrastructure agility differ from simply using multiple cloud providers independently?
The biggest thing, and I kind of glazed over this before, is how your skill sets are different. If you're using OpenShift, there's two sides to this. The ability to be agile enough to move workloads, and then the knowledge gap. So when you go into a different cloud provider, you obviously want to be, some level of training around nomenclature, feature sets, automation, etc. for that given environment, administrating security ruling, right? Network policy functionality, IAM type stuff. There's a whole host of different things you're going to have to learn per environment. And not that you don't have to learn that when you start using OpenShift as kind of the middleman in these different environments, but it limits how much you're going to be using in these individual cloud providers, quite a bit. You may not be leveraging Lambda functions in AWS. Instead, you would use Knative to do fundamentally the same thing, right? You may not be leveraging hosted Mongo services in different environments because now you're using Mongo hosted in OpenShift, right? Same thing with Elastic or whatever tool. So instead of using all these a la carte as a service functions, you're going to be more married up to what's inside of OpenShift. And when you're thinking about the security policy of things, like even IAM ruling, you're doing almost all of your security management inside of OpenShift. The only thing you'd be doing outside of that is enough security and automation to get the cluster delivered into these different environments. So your knowledge of those different cloud providers can be much, much, much smaller in theory, right? Now, from an automation perspective, if you were going to move something from AWS to Azure and it was just in a VM, there's some ways you can do things like automated data dumps. Like you could use Clonezilla and similar type technologies to do a bit for bit copy of a VM and move it to another environment. That would be slow, right? And not advantageous. If you're starting to use interconnected services in different cloud providers, going back to like SNS and Lambda and all these other things, you'd have to find an equivalent service inside of different cloud providers and then translate those capabilities over into that functionality, which is all re-architecture, redesign, code rewriting, etc. So that's not great. That's going to take a lot of time. If you're in OpenShift in all these environments, it's just using the tooling that you deploy inside of OpenShift to do all these different things. So you would set up a container native service for doing Knative instead of using Lambda, as I mentioned earlier. You would then, if you're going to move from one environment to another, your storage could be auto cloning into those different environments on an interval. Every 5 minutes, maybe it's cloning, or it could be synchronously replicated, in which case you're just provisioning the same things in the other environment. The only thing that's changing is, how did I get the OpenShift cluster initially set up? And again, OpenShift's, let's just use the IPI installer as an example, automates setting up clusters in all traditional hyperscalers. So you pick the environment, you say this is the requirements for it, and you run this one simple command and it builds out the cluster for you.
Got it. And, the Broadcom VMware acquisition is top of mind, with the pricing concerns that we're hearing from organizations. What's a realistic timeline for transitioning from VMware to OpenShift?
I think it's a little bit of a loaded question, but I'll tell you the reason why. And I think it's because it depends on how much you've invested into VMware. There's really three different pieces of this. There's an assessment piece. We got to look at how much virtual machines you're actually running and what kind of workloads you're running inside of those environments. Thing number two would be building out the OpenShift virtualization cluster, which that usually takes a couple of weeks. And with that, it's pretty easy to get enabled around it once it's set up. But and when I say enabled, I mean getting the environment configured in such a way that it would be able to mirror some of the capability sets from your old environment. The third thing would be upskilling and optimizing your workloads. So if you're looking at it from that perspective, this could take several months because we got to not only move your VMs over, which can happen rather quickly. OpenShift's migration toolkit for virtualization lets you move things from VMware automatically into OpenShift, from Red Hat OpenStack automatically into OpenShift, right? So you have both of those kind of benefits. But in addition to that, though, once everything is loaded, we want to start optimizing our tooling. So if you're doing things like Terraform against VMware for how you spin things up, we're going to have to change those tools over for how they work against something like OpenShift. You're going to probably be using Helm and customize a lot more, frankly. And then it's really upskilling your engineers to really know how to use the platform. And that's what takes time. Unless a company goes, whatever, we're going to turn off the lights to VMware tomorrow and turn on OpenShift, and we're just full bore in, which you never see that happen. There's always like 80% of their time is spent maintaining and 20% of their time is spent building. Yeah,
bit of a transition, yeah. So on that note, what are the biggest challenges that organizations face when implementing OpenShift, and how might you address them?
There's, different things. First of all, the architecture design of OpenShift is different than VMware. Normally, when you're running VMware, you might run a single rack node of VMware, and you put a VMware manager inside of it. You can run multiple though, and most people do. OpenShift is designed for containers, and it's Kubernetes based, right? So you traditionally have 3 nodes that are running the control plane functionality. That's the scheduling of workloads, containerized or virtual, doesn't matter. That's the API endpoint, the administrator functionality, all that kind of stuff. You can, in smaller environments, aggregate that functionality with running your workloads. However, as you go to production and you're really running, tons of workloads from a high availability perspective and just being safe about things, that's usually an isolated set of nodes that's outside the realm of where your workloads run. Now, from a licensing perspective, you don't pay for those machines, but you physically have to have the hardware available for it, right? So there's things like that. Is usually you're thinking about a little bit more nodes in your node groups. Think of 3 additional nodes minimum for every cluster of VMware you currently own, on average. They don't have to be beefy pieces of hardware. So this isn't like, oh my gosh, 128 cores and, a terabyte of RAM. We're not talking about stuff like that. They're much smaller, but it's still something you'd be cognizantly aware of. The other thing that usually shocks people at first is because OpenShift is Kubernetes, every VM and every container gets its own IP address, and you get a subset pool for every worker node in the environment. So this means large CIDR blocks that have to be pre-provisioned and given to OpenShift. Now, depending on your use case, you don't have to worry about necessarily overlapping IP addresses. But when I tell a customer I'm going to need 2/16s for my cluster, they go, oh, wait a minute, that's eating a lot of the CIDR space in our network. And the reality is, it really just depends on how things are set up. A lot of times things inside of OpenShift are just talking to things inside of OpenShift. And on premise, if that's the case, it's more or less a NATed environment where those IP addresses are confiscated away. It's only if you have something that needs to be reached outside the cluster that you have to worry about overlapping IP addresses. So it depends on your use case, and we can obviously help customers work through that. Beyond that, it's just a different world. And people are, quite frankly, they don't know what they're getting themselves into initially. And so they'll have billions of questions, which I'm all for answering and helping them work through. So is every member of our team. But yeah, it's just different.
Yeah, well, I appreciate you spending some time with us today, Derrick, and to the viewers. Thanks for watching. A little bit about Shadowsoft. We've been in business for 16 plus years, really focused on helping organizations adopt modern technologies and modern practices. We have specializations in infrastructures and cloud platforms, automation, observability, and security. And what makes us different to some other consultants or integrators is our deep domain expertise with Red Hat and our end-to-end service delivery model. So we can help with assessing modernization readiness, help with the deployment of the platforms, and help with the enablement of the team so your teams can operate and run the new platforms into the future. So I guess, Derrick, any final thoughts or advice for the audience before we wrap up for today?
Advice, don't be afraid of what you don't know. Be willing to learn and open your eyes. It's less complicated than you think there is. There is a lot to learn, but that doesn't mean that it's complicated or be outside your skill set. I think that most people, once they spend enough time using it, it becomes a much more apparent how things work. This is a fear of the unknown, I think, more than anything else.
Mm-hmm. Well, appreciate it, Derrick. We'll see you on the next webinar.
Thanks.
All right.